Good morning, math. In this problem, we are asked to find the value of f of 0, given that the composite function f of x is equal to x squared minus x plus 1. Now, let us get started. When you first see this problem, the first thing you probably want to do is substitute 0 for x. If you do that, you can immediately see that f of 0 is equal to 1. However, many people do not know what to do next from there. The key point of this problem is to think about fixed points of the function f of x. We will talk about fixed points in more detail later. But for now, let us try substituting 1 for x. Then we obtain f of 1 equals 1 squared minus 1 plus 1, which is equal to 1. Let us call this result statement 1. This result means that x equals 1 is a fixed point of the function f of x. When we substitute 1 for x, the value of f of x is also 1. In other words, 1 is a point that does not move under the function f of x. Such a point is called a fixed point. Now, let's talk about some properties of fixed points. For a function f of x, a number alpha that satisfies f of alpha equals alpha is called a fixed point of the function f of x. Fixed points have the following property. Since f of alpha is equal to alpha, f of alpha is equal to f of alpha, which is equal to alpha. That means any fixed point of f of x is also a fixed point of f of x. In the same way, f of alpha is equal to f of alpha, which is equal to f of alpha, which is equal to alpha. Therefore, a fixed point of f of x is also a fixed point of f composed of itself any number of times. However, it is important to note that the converse is not true. In this problem, we have found that x equals 1 is a fixed point of f of x, but that does not necessarily mean that x equals 1 is a fixed point of f of x. Still, it is a possibility. So it is important to check whether x equals 1 is actually a fixed point of f of x. Now, let us return to the problem. Let us set f of 1 equal to p. Then, from statement 1, we obtain f of p equals 1. On the other hand, since f of p is equal to f of 1, f of p must be equal to p squared minus p plus 1. But f of 1 is p, so we obtain the equation p squared minus p plus 1 equals p. This quadratic equation has a repeated root equal to 1, so we find that p equals 1. Therefore, we conclude that f of 1 equals 1. That means x equals 1 is also a fixed point of the function f of x. Next, let us consider the case when x equals 0. Substituting 0 into the given equation, we obtain f of 0 equals 0 squared minus 0 plus 1, which is equal to 1. Now, let us set f of 0 equal to q. This value q is what we are trying to find in this problem. Then we have f of q equals 1. Let us call this statement 2. Now, let us continue. Since f of q equals 1, we have f of q equals f of 1, which is equal to 1. From this, we obtain the equation q squared minus q plus 1 equals 1. Solving this equation, we find that q is either 0 or 1. So now the answer has been narrowed down to two possibilities. If q equals 0, then from statement 2 we get f of 0 equals 1. But this contradicts the assumption that f of 0 equals q, which would be 0. Therefore, q cannot be 0. So we conclude that q equals 1. Since q equals 1 satisfies f of 0 equals q, we finally obtain the result that f of 0 equals 1.